Welcome class. This is our lecture on ordinary differential equation and we are discussing the chapter called equation of first order and first degree. In the last lecture we have done some question on reducible to variable separable. Today we are going to take very critical questions which are asked in civil services and IFoS examination and of such kind of questions which demand our attention. Before I start reading and solving this question, I would like to make an important comment, that is, many candidates have asked me as to how they can find out the differential equation and its method. So that I will be able to explain very lucidly once I am done with all those topics, that is all the methods, and then I can very easily make distinction as to how to go about question just by reading that question. So this is the question, and this question reads that we have to solve x dx plus y dy divided by x dy minus y dx is equal to 1 minus x square minus y square divided by x square plus y square and the whole to the power half. This question was asked in Civil Services IS examination 1999 for 20 marks. So before solving this question, what is the feeling that we get when we read this question? Prima facie, this appears to be a question of exact form, but indeed that could also be solved by that. But we are seeing here x square plus y square, and over here also they are common. So if we put some substitution, we can also solve it by variable method. So in differential equation, solution to the differential equation can be found by any method. All we have to do that we must have the robust understanding of those methods. So now I am going to solve it by variable separable. So if I put, you can see x square plus y square. So we can take the polar form. That is, if we put x is equal to r cos theta and y is equal to r sin theta, then we can reduce this. How? We will be seeing. If I take x square plus y square, this is r square cos square theta plus sin square theta. So this is 1. Alright. So we'll call this as equation 1. Okay. Similarly, if I divide y by x, that is y by x is equal to r sin theta divided by r cos theta. So we get this as tan theta is equal to y by x, and I am calling this as equation 2. Alright, now if I differentiate equation 1 with respect, differentiate equation 1 with respect to x, we are going to get 2x dx. Actually I am doing partially, so I can write it 2x dx plus 2y dy is equal to 2r dr. So we are seeing we are getting 2 common in all of these, so we can cancel it out. So we get this our third. Alright, now if we differentiate this equation, tan theta, this becomes tan theta is equal to dy by x. Alright, so this becomes sec square of theta d theta is equal to x square x dy minus y of dx. So we can see we have got x dx plus y dy here, and we have got this value. Okay, similarly we will find for the denominator. So we can write x dy minus of y dx is equal to x square sec square theta. So we can put the value of x from here, that is r square cos square sec square theta. So these two get cancelled because that is the reciprocal of cos sec. So we get this as r square d theta. So we call this as 4. So this is essentially 3 divided by 4, that is the LHS of this part. So I erase some of the portions. So here, as I have rubbed it here, I can write this x dx plus y dy divided by x dy minus of y dx is equal to, this was our r dr and this is our r square d theta, and this could be written as 1 minus, this is x square plus y square is equal to r square, so we can put it like this, divided by r square to the power 1 by half. So we can see here that we have got some of these values, so we can cancel this one out one time, so we write it as dr by r d theta, and this r can be taken out over here, this can be written, so this r and this r also get cancelled. Now we can write this as dr by 1 minus r square is equal to d theta. So we got our equation. So if we integrate this, we will get sine inverse of r is equal to theta plus c. So we can plug back the values. R was how much? It was, we can write it, before doing that we can send the sine inverse to that side. So r is our sine theta plus c. So r was how much? X square plus y square is equal to r square. So r was our x square plus y square to the power half is equal to sine. Theta was our tan inverse y by x plus c. So we have got our answer. We could have also simplified, and that could be written as x square plus y square. If we square it both sides, we get sine of square tan inverse y by x plus c. So we have got our answer, and it could also be done by other methods which are lengthy. I will just give an illustration as to how we arrive at this, but that is little bit lengthy. Again, the substitution will be the same, only the approach is different. That is, if we put x is equal to r cos theta and y is equal to r sin theta. Here what we are doing, we are differentiating as dx with respect to d theta. So what we get over here, we get dr by d theta cos theta minus of r sin theta. Similarly here also we can write it as dy by d theta is equal to dr by d theta sin theta plus of r cos theta. Now here we are not having theta, but we will divide by d theta on numerator and denominator. That is, if we write it like this, dy by d theta divided by x dy by d theta minus of y dx by d theta, then if x is what? R cos theta, and what is dx by d theta? We can copy it from here, that is dr by d theta cos theta minus of r sin theta. Okay, and what is this y? Y is r sin theta, and we can write it again as dy by d theta, that is dr by d theta sin theta plus r cos theta. Okay, similarly in denominator we have to just change, here it is x, so we have to write it as r cos theta, and we are having dy by d theta, so we can take it from here. So that is dr by d theta sin theta plus r cos theta plus, here it is minus sign, so we can write it as r sin theta dx by d theta. So this is dr by d theta cos theta minus of r cos theta. So we can see here it is r square sin theta cos theta, here it is r square sin theta cos theta. So here it is minus sign and here it is plus sign, so this can be cancelled. Okay, similarly we can see here dr by d theta, okay, and this is sin theta cos theta. here also minus of dr by d theta sin theta cos theta. So this can be cancelled out. Okay, so here we can write this as r times, if we take r and power, this is how much, if we take r dr by d theta, so this is cos into cos is cos square theta, plus here dr by d theta, sin into sin is sin square theta. So we can write this as. Similarly over here we can write our this one and this one was cancelled, so what we are left with, r cos theta cos square theta minus minus become plus, so this become how much, this becomes r into r is r square, so cos square theta plus sin square theta, and this is our how much, this side 1 minus r square divided by r square half. So we know this identity is 1, so we are left with dr by d theta divided by r is equal to 1 by. So if we recall in the previous method, we have reduced it to the same format. So why I did by this method also, just to highlight the point that the method that you are going to choose in examination, that is of utmost importance, because if you save time and if you do by ligand method, which I did in the before this method, that would be advisable to do in the examination rather than going through this lengthy calculation. Now I am going to take up the next question. Now we are going to take the next question. So the question reads as, you have to solve x to the power 4 dy by dx plus x cube y plus cosec of xy is equal to 0. First and foremost, before solving, it is apparent that this is first order differential equation and a first degree as well. And here we can see here that here x and y. So we can ask the question, can we reduce it to variable separable? If we are going to put xy is equal to some other variable, that is say t, if we put x of y is equal to t, alright, then we are going to differentiate it. So this becomes, we get, if we call this as equation 1, so we can keep the x constant and y, so we can write as x dy by dx. Now I am going to keep y constant and differentiate with respect to x. So dx by dx is 1 and here dt by dx. So we will put it into this original equation. Before that, I will like to simplify it. That is, if I write the original equation dy by dx plus, if I just divide by x to the power 4 thoroughly in this equation, this becomes 1, this becomes x cube by x to the power 4 y plus 1 by x to the power 4 cosec. So here we are left with only 1, and this can be eliminated. Now I will put my dy by dx into this equation, that I can write as dt by dx minus of y. Now here the coefficient of dy by dx is x, so I will divide it, okay, plus y of x plus cosec, I can write here as t as well, and in denominator I can write x to the power 4. So if we further simplify, this becomes dt by dx 1 by x minus of y by x plus y by x plus cosec t x to the power 4 divided by x to the power 4. Now this one will get cancelled. Further it is simplified. Now I will multiply by x on both sides. So this becomes dt by dx plus cosec t divided by x cube is equal to 0. If I send it here, and now it is in a position to, the variables can be separated from here on. I will write on the top of it now. So this equation is dt by dx plus cosec t divided by x cube. So we can interchange the variables. So this becomes dt by cosec t plus dx by x cube. This can be written as sine of t dt plus dx by x cube is equal to 0. So if we integrate, what is the integration of sine t? That is minus of cos t. What is the integration of x to the power n? We know the integration of x to the power n is x to the power n plus 1 divided by n plus 1 plus c. So here n is minus 3. So what we get here, we can write it as, so this is effectively is equal to some constant. So I can further simplify and write it as cos, what is the value of t? xy, because it is essential that we put back the value in the format that we are given. So this is the answer, cos xy plus 1 by 2x square is equal to c. So it is imperative that you, if you can really understand that what is the substitution we made, you can very easily solve this answer to this question. Okay, the next question we are going to take up. So this is the third and the last question for this session. Question reads that dy by dx is equal to 2y by x plus x cube by y plus x times tan y by x square. This question was asked in Indian Forest Service 2014 for 10 marks. Now again, this seems to be a variable separable, but here first of all I will try to solve it through a simple method and another method that is bit tedious. Here I will take my assumption as y by x square is equal to some variable, and I will try to find out whether I am in a situation to really reduce it to a better equation and make it solvable through variable separable. It is not about the hunch that you take, but there are certain patterns in mathematical equation. If you can readily see and perceive and do, we can really do it. So let us get started with this solution. So my claim is that I am going to put y by x square is equal to, say, a variable t. So this can be written as y is equal to x square t, and I call it as equation 1. Now I will differentiate it with respect to x. So differentiating equation 1 with respect to x, we get dy by dx is equal to 2 times of x t. Okay, because I have kept t as constant. Now I am going to keep x square as constant. So this gives us dt by dx. Now I am going to plug the value of dy by dx into the original equation here. So what this is going to give me, I will write now. So this gives me 2 times xt plus x square dt by dx is equal to, now at the same time I will put the value of y. Y's value is x square t. So this is your x square t divided by x plus x cube by y. What is my y? X square by t. Okay, plus x of tan y by x square is t. So see, we have reduced this argument of tan from y by x square to t. Okay, so now we are going to make some simplifications. See, x square divided by x, what is it? It is x. Now here x cube by x square. So this can be written as only x. You can see 2xt readily we can cancel out. Okay. Now I will write my dt by dx x square. I can cancel here, but I will write it as x square. I will cancel it later onwards. So I can write it as x by t plus x by, I will further decompose tan t as sin t and cos t, and I will take the LCM, that is t cos t. Okay, and this is, I can take x as common, so here I have to write cos of t and here t sin of t. Now I can cancel x square from here, so I can write it as x. Okay, so I get my dt by dx x is equal to t times cos t plus t sin of t. Now I can see it is separable, and now I can solve it. So I will write it here in the upper portion, my equation. So this becomes x dt by dx is equal to cos t plus t sin t divided by t cos t. I can send it here and this one here and cross here. So this becomes t cos t divided by cos t plus t sin t dt is equal to dx by x, and I am putting integration sign on both the sides. So here we can see that the derivative of this one is t cos t. We will check it out. So if we differentiate this, it becomes minus sine of t. Put cos t plus t sine of t is equal to u. So minus sine t plus t. If I keep constant t, this becomes t cos of t. If I now keep this one, then this becomes what? The cos t plus t sin t is equal to u. So we are taking the derivative. So this is minus of sin t plus I am keeping t cos t as a constant, and now I am going to keep sin t as constant and I have taken this derivative. So this becomes du dt. So this and this one get cancelled. So our claim was right that t cos t dt is equal to du. So we can write this as du divided by u is equal to integral of dx by x. So we can write this as log u is equal to log x plus log of c. So we can write this as u is equal to x of c. What is our u? U is cos t plus t sin t. So we can write cos of t. In place of t, we can plug back the value, that is y by x square, plus of t. T is what? Y x square into sine of y by x square is equal to x times c. So this is our answer. We have got our answer not by fluke. So this is the answer merely by putting this. Sometimes there is actually putting the values 2 times. Okay, so we can do that method also. That method is that we could have taken y is equal to v by x, then we have reduced again, and then we have taken y is equal to t of x. So we have to take the same thing at 2 times, and we can write it as t x square. So this effectively gives us. So if we use this method, what we will get, that our process will be very lengthy, but here we can see we are actually doing the same thing. The reduction is happening just by a stroke of one substitution, but here there is substitution and further substitution, and that really further complicate the equation. So this is the answer for this question, and this was asked in Indian Forest Service examination. Thank you for watching. Please like, share and subscribe.